All right. Today we're on lesson 9 of multiplying and dividing multi-digit numbers. Let's analyze and try an algorithm that uses partial products. Guys, if you are somebody who likes to figure out why things work, today's lesson is for you because it's pretty fun. So we're going to start on page 45 with which one doesn't belong. And I'll give you, no, not raising your hand to share. I'll give you a couple minutes. Go ahead and do that. Make a couple notes and then we'll share. Okay, let's share some answers. Which one does not belong? All right, Jerica.
Because there's 7 50s and there are 6 pluses.
So, yeah, so it's adding a whole bunch of 50s, which looks very different than the others. So maybe it's D. Okay, Gage, what do you think?
All of them because 7 times.
Oh, wait. We're not allowed to say all. I want you to pick one.
No.
I'm making you pick one.
No.
If you... No. I'll come back to you. I want you to pick one that doesn't belong. Okay. All right, Hadley?
I also said D because it's the only one that doesn't apply to multiplying.
Okay, so it's not multiplying, yeah. Keston?
I thought C because it's the only one with 10. Like none of the other ones have a 10 in them.
So that one has a 10. Okay. Cade?
This isn't one, but I just noticed something. I noticed that all these problems equal the same thing. I was going to say that.
Raise your hand if you figured that out. So if you do the math, they all equal the same amount, which is 350. So they all equal 350. So that tells us how they're alike, doesn't it? But let me hear, what's another one you think? Let me hear one more. All right, Gage, you picked one.
7 times 50 because it's the only one with 2 numbers in it.
So it only has 2 numbers. Okay. So were there expressions that you knew right away were equivalent? Which ones and how did you know? Okay, Kate?
I knew 5 times 10 times 7 was equal to 7 times 50 because 5 times 10 equals 50 times 7 would equal 7.
So you noticed that 5 times 10 right there, didn't you, is 50. Yeah, so they would have to be equivalent. Delaney?
I found out that 7 times 50 was equal to 3 times 50 plus 4 times 50 because 3 plus 4 is 7.
Oh, yeah, the 3 plus 4 is 7. Okay, one more. All right, Brayden.
I have one for the first one.
Okay.
I think B doesn't belong because it's the only one that has 2 different, it has multiplication and addition. Yeah.
So it has 2 operations in it,
Yeah.
so maybe it's B. Okay. All right, so I think all of you are correct. So, close your books, mark your spot with your pencil. Okay, so I want you to look up here. What do you notice? What do you wonder? Vivian.
I noticed that all of them are different colors.
We have 3 different colors up here. Good. Quinn.
I noticed that 7 times 100 is 700.
7 times 100 is 700. Okay. Okay, Michael.
I noticed that the numbers up top are the ones that there are timesing by 7.
Oh, okay. So that this was the number that they must have multiplied. Okay, Madeline.
I noticed that it's a rectangle.
It's a rectangle. Good. Coral.
That they broke apart the number.
They broke apart what number?
They broke apart the 100 and then the 20 and then the 4. And I bet that they had the 7 for timesing that or like adding.
So do you think maybe the original problem might have been 7 times 124 maybe?
Yeah.
You might be right. Let's do it. Okay, Brooks.
I agree with Carl, and I think that if they were writing it vertically, that it would be 124 on the bottom because they have all the factors and they're adding them up.
Oh.
And that's what you do if you have more than one number on the bottom.
On the bottom? Okay. Yeah. Okay.
I think that that 700 plus 140 plus 28 would be the answer, and I think that'd be 868.
Did anybody else get 868? Yeah. I didn't add it up, but that seems reasonable. This is Renee. He's on his way. You're welcome. Bye. Brooks, you get to go. You didn't even know. Surprise. I hope it's something exciting.
Why do I have to make it?
I was going to say, math is your favorite. All right. There may or may not be a video posted tonight. We'll see. Hopefully. Okay. Oh, I forgot to pause it. All right, now we're good. So when we add it up, we would get 868, right?
Uh-huh.
Okay. Oops. All right. Oh, we still have hands. I'll take 2 more. Emma.
Okay, I noticed, and I noticed that 20 times 7 is 140.
It is 20 times 7.
And I wonder why they have colors in the boxes.
I'm wondering that too. Strange. Okay, one more. Kara.
I wonder, why are they even doing this?
Why did they do this? Yeah, why did they divide it up and color it? Does this have something to do with what we're going to do next, maybe? I don't know. Let's find out. Okay, so, all right, you can open your books again.
Yay.
Page 46. Okay, but you're not starting. So put those pencils down. Okay, so activity 1. Noah drew a diagram and wrote expressions to show his thinking as he multiplied 2 numbers. Does that look familiar? Yeah. Bye, Brooks. We'll see you tomorrow. Okay, so how does each expression represent Noah's diagram? Be prepared to share your thinking with a partner. So, guys, you're going to work with your math partners.
Okay.
Number 2, this is where it really gets fun. Later, Noah learned another way to record the multiplication as shown here. Make sense of each step of the calculations and record your thoughts. Be prepared to explain Noah's steps to your partner. And then number 3, you're going to complete the diagram to multiply 217 times 8. And then you're going to use Noah's recording method to check your work. Okay? Now this is where the puzzle comes in. Because in question 2, you're going to figure out his strategy. And question 3, you're going to try it on your own. Okay? When we synthesize, I will go over how to do Noah's strategy, okay? All right, 10-ish minutes, work with your math partner, and meet me back here on the... All right, so we're going to take a look at number 3 for our synthesis today, okay? So, first we're going to use the diagram. So we're multiplying 217 times 8. So, did you guys notice at the top they just broke up 217 by place value? Did you notice that? Okay. So we've got ones, tens, and hundreds. Okay. So first off, we're going to line them up and we're going to do 8 times 200. Raise your hand. What is 8 times 200? Gauge.
1,600.
So that would be 1,600. Then we go to our tens place, and we're going to do 8 times 10. What is 8 times 10, Charlie? It's not 800, just times 10.
Oh, 80.
80, it's just 80, yeah. And then we go to our ones place, and we're doing 8 times 7. And what is 8 times 7? Mason?
56.
56. Okay. Guys, you're not done there. How do you find the answer? Once you fill in the diagram, what do you do next, Hadley?
You could either multiply all those numbers up there with the basic algorithm, or you could just do, like, add all of your answers that you got.
So when we're using this method with the diagram, then we just add our 3 answers. So 1,600 plus 80. What do we get when you add those two? 1,680. And then lesson 9?
We were on 8.
Oh,
You're good.
I'm still one ahead. Is she on 8?
Yes, you're fine. Are we rocking this?
Yeah.
These guys know
This is
it.
really
Great.
pretty
With the boxes or without the boxes?
without.
And you can use either, right? Both work, but don't confuse yourself.
Okay. And then we have to add 56. What do we get, guys, when we add 56?
36. No.
Yeah. 736.
736.
Okay.
Oh, yeah.
So we're pretty good with that one. Then Noah has his method where he's recording it differently. Okay? So if I'm using his method, they gave you hints over here. So if I'm using his, I start with the ones place. What is 8 times 7, everybody? 56. So I'd write 56. And then he did 8 times 1. Is that really a 1 though? No, it's a 10. So what is 8 times 10? 80. And then he did 8 times 2, but it's not really a 2, it's...
2.
And what is 8 times 200?
1,600.
Now, if we do it correctly, we should have the same products that we had with our diagram. And so then we'd add them up, and we should get... What should we get, guys? 1,736. So do you guys see how we did that? So here's my question. How do we know if we have finished finding all of our partial products? How do we know? Okay?
You get the same answer as you did in the boxes.
Okay, so maybe you always just double check. That seems kind of cumbersome, doesn't it? But yeah, maybe, or maybe you can visualize the boxes. Jace,
If you just multiplied it normally.
if you did a regular problem.
Yes.
Okay. What about place value? Is that what you were gonna say? Okay, say it.
If you would use place value for the 1,736, minus the
Oh, we don't need to. Excuse me. We don't need to subtract. I'm hiccuping and coughing. This is weird.
wouldn't you do?
So if we've gone through and we've done our ones place,
You would do 1,600.
no. We're looking at how do we know we're done. So guys, eyes up here. If we've gone through and done each place value. So 8 times 7, that was our ones place, right? 8 times 10, that was our tens. And 8 times 200 was? And I don't have any other numbers. I don't have any thousands over there. So I know that I have found all of the partial products when I have gone through each place value. Okay? All right. Questions? Okay. All right. Here's our launch. What strategy would you use to find the value of 8 times 3,419? Okay. So we have Noah's strategy and we have Mai's strategy.
Oh, it's just reversed.
It's just, it looks like it's just reversed. Okay, anyway, you're going to work with that before I give away any answers. You and your partner, about 10 minutes, activity 2. So, Noah's strategy, guys, is not as confusing as I think you're making it. So, where is question? Okay. Let's see, A or B, which one do you guys want to use Noah's strategy with? Just say it. A. 4 times 5342. So let me get a blank page. Darn it. It didn't give me a blank page. Okay.
It's on this page.
It did?
Yeah.
I thought it went into, yeah.
No. Like if you go backwards, like that one's a pretty blank page.
That's the cool down page.
Just so
just
You
use
look
it
at
and
the
then
cool
erase.
down. Okay. I'll just do it right here in this little box. Good luck. Don't you have faith in me? Come on.
No.
All right.
No.
Yeah, I'm going to give it a try. Okay. So,
No.
Noah's, yeah, that's not going to work.
Yeah.
I want to do it on here. There isn't. Okay, I'm going to do it down here. All right, what is it? 5,342?
3,000.
5,000.
No, it's 5,342 times 4.
Times 4. Okay. All right, so if you need to, do this with me, okay? If you already did it, check your work. Okay, now this is Noah's strategy. Are you guys ready? So Noah goes by place value. So Aubriella, your eyes need to be up here, honey. So he starts with ones. Okay, so 4 times 2. What is 4 times 2? 8. So then he would put an 8 for his first row. Then he moves on to the tens. And we have a 4. But guys, that's not a 4. What is it?
40.
40. And he does 4 times 40. What is 4 times 40?
160.
Just say it. 160. What did I just hit? Oh. Okay. 160. So that's his next row. And he lines them up. Then he goes to the hundreds place. And there's a 3. But guys, is that a 3? It's 300. So what is 4 times 300?
1,200.
1,200. Okay, then we go to the thousands. And it's 4 times 5. But guys, is it really a 5? It's 5,000. What's 4 times 5,000? 20,000. Okay. Okay, then I've run out of room. You add them up. Do you guys see how my place values are nice and neatly lined up? That's part of Noah's strategy. So 8 plus 0 plus 0 plus 0 is 8. 6 plus 0 plus 0 is 6. 1 plus 2 plus 0.
3,
1 plus 0
1,
and 2, right? 21,368. Okay. So guys, the reason it's important to understand Noah's strategy is it's using place value, but it's also showing you how important it is to line up your digits. Because if they're not in the right place, you're going to get the wrong answer, right? Okay. All right, does that make sense? Okay, you might not like Noah's strategy, but if you understand his strategy, it's going to help you with the basic algorithm. Okay, Gage.
You wrote the answer in my book.
I what?
You wrote the answer in my book.
I did. You just had to add them up.
Yep.
Yep. Okay. All right. You guys may go do your cool down. And, yep, you can use any strategy for your cool down.